Hello students, today we will continue our study of chapter 2, linear programming. This time we will study a graphical solution for linear programming. Graphical solutions of linear programming models. Following the formulation of mathematical model, the next stage in the application of linear programming to a decision-making problem is to find the solution of the model. A common solution is to solve algebraically the set of mathematical relationships that form the model, either manually or using a computer program, thus determining the values of the decision variables. However, because the relationships are linear, some models and solutions can be illustrated graphically. So, pwede nating makuha yung solution graphically. Okay? The graphical method is realistically limited to models with only two decision variables, which can be represented on a graph of two dimensions. Mas madaling sagutin yung mga tinatawag natin na models na merong lamang dalawang decision variables. Pagka tatlo na, medyo mas mahirap nang gawin, at lalo na pagka nagkaroon ka na ng apat or higit pa na decision variables, ayun talagang hindi mo na magagraph yun, mahirap nang i-graph yun. At kung magagraph mo man, ang hirap makita ng solution. Okay, so later on makikita nyo na dun pa lang sa two decision variables pa lang, medyo mahirap nang gawin. What more pagka 4 or more decision variables, ano? Computer na ang pwedeng makasagot ng ganun. Although the graphical method is limited as a solution approach, it is very useful at this point in our presentation of linear programming, in that it gives a picture of how a solution is derived. Graphs can provide a clearer understanding of how the mathematical solution approaches presented in subsequent chapters work, and thus a better understanding of the solution. Okay, sige, magsimula na tayo sa ating pag-aaral ng graphical solution. Graphical solution of a maximization model. Okay, so magsimula tayo sa maximization model. Okay? So the product mix model will be used to demonstrate the graphical interpretation of a linear programming problem. Okay, kung maalala nyo yung in-example natin nun sa Beaver Creek Pottery Company. Okay, so ito yung kanyang complete linear programming model. Maximize z is equal to 40x1 plus 50x2 subject to x1 plus 2x2 is lesser than or equal to 4 hours of labor, and for the material constraint or clay constraint 4x1 plus 3x2 is lesser than or equal to 120 pounds of clay, where x1 and x2 is greater than or equal to 0. Okay, so alam naman na natin na ang x1 ay number of bowls, tapos yung x2 is number of mugs. Okay, so meron tayong coordinates dito, no? Figure 2.2 is a set of coordinates for the decision variables x1 and x2, on which the graph of our model will be drawn. Okay, so yung tinatawag na vertical axis, okay, for x2, for mag. Okay, sa example natin, for mag. Yung naman horizontal axis is for x1, which is the balls. Okay. Note that only the positive quadrant is drawn. Okay, the quadrant where x1 and x2 will always be positive because of the non-negativity constraints. Kasi kung titingnan natin to sa math, okay, kung sa math natin to gagawin, ganito ang mangyayari dyan eh. Okay, meron pang actually ganyan yan eh. Tapos ganito. Okay. Itong part na to, okay, yung part na yan, that is actually negative. Bakit? Kasi, nasa na ba yung ballpen dito yan? Kasi, ito, negative 10, negative 20, negative 30, negative 40. Ito din naman, negative 10, negative 20, negative 30. Kaya lang, hindi na pinapakita yan. Kasi, those are non-negativity constraints. Okay? So, itong part lang na to ang pinapakita yung positive. Itong part lang na to. Okay? Yan lang ang ating concern. Dahil, wala naman tayong tinatawag na negative items. No? Okay, so let's continue. So, yung first step, okay, is constraint lines are plotted as equations. Kukunin natin yung dalawang line, okay, line 1 and line 2, para makapag-plot tayo. Okay, makapaggawa tayo ng graph. The first step in drawing the graph of the model is to plot the constraints on the graph. This is done by treating both constraints as equations or straight lines and plotting each line on the graph. So, meron tayong line 1, okay? Ayan yung labor constraint. Okay, line 1, labor constraint. x1 plus 2x2 is lesser than or equal to 40. Yung line 2 naman, okay, which is the material constraint or clay constraint is 4x1 plus 3x2 is lesser than or equal to 120. So, yan yung line 2. Okay, gawin muna natin yung line 1. Let's consider the labor constraint line first. x1 plus 2x2 is equal to 40. So, i-assume muna natin na equal to 40. Okay? So, a simple procedure for plotting this line is to determine 2 points that are on the line and then draw a straight line through the points. One point can be found by letting x1 is equal to 0 and solving x2. So, sa pagkuha ng line, okay, line 1 muna, yung x1, ilagay mo muna siya as 0. Okay? Para makuha natin yung x2. Okay, so tatandaan yun. For line 1, let x1 be equal to 0. So, ang makukuha mo doon, 0 plus 2x2 is equal to 40. x2 is 40 divided by 20 is 40 divided by 2 is 20. Thus, 1 point is at the coordinates x1 is equal to 0 and x2 is equal to 20. A second point can be found by letting x2 is equal to 0 and solving for x1. So, kanina, yung x1 ang 0. This time, ang x2 naman ang 0. Okay, so x1 plus 2 times 0 is equal to 40. x1 is equal to 40. Now, we have a second point. x1 is equal to 40 and then x2 is equal to 0. Thus, for the labor constraint, okay, labor constraint line 1, the first point is x1 is equal to 0 and x2 is equal to 20. And second point, x1 is equal to 40, x2 is equal to 0. This is line 1. Okay, nakuha nyo sana yun, ano? Okay, so ito yung ginawa nating line 1. Okay? So kung gagamit tayo ng highlighter dyan, okay? Natatandaan nyo to, no? Natatandaan nyo itong ginawa natin na una. Ginawa muna natin na yung x1 ginawa nating 0, which is ito yun. Okay? x1. Yan yun. So, 0. Nung kunin natin kung ilan yung x2, nakuha natin is 20. Okay? So, kaya nandyan yung first point. Okay? Tapos, nung ginawa natin yung dun sa ikalawa, nung ginawa naman nating 0 yung x2, okay? Ginawa nating 0 yung x2. This time, yung x1 is 40. Okay? Kaya nandun yung dalawang point na yan. Okay? So, I hope nakuha nyo yan kung bakit nagkaroon tayo ng line dyan. Ano? So, the line on the graph representing this equation is drawn by connecting these 2 points as shown in figure 2.3. Okay, so meron na tayong line 1. We draw the line for the clay constraint. Line 2 naman ngayon. Ano? The same way as the one for the labor constraint. Ganon din yung gagawin natin by finding 2 points on the constraint line and connecting them with a straight line. Okay, so dun sa second constraint, clay constraint, so let x1 is equal to 0 and solve for x2. So 4 times 0 plus 3x2 is equal to 120. Okay, x2 is equal to 120 divided by 3. So, x2 is equal to 40. Okay, performing this operation results in a point x1 is equal to 0, x2 is equal to 40. Okay, that's the first point sa line 2. Okay? Next, we let x2 is equal to 0 and then solve for x1. So, 4x1 is equal to 120. x1 is equal to 120 divided by 4. x1 is equal to 30. This operation yields a second point. x1 is equal to 30. x2 is equal to 0. Thus, for the clay constraint, line 2, the first point is x1 is equal to 0. And x2 is equal to 40. And the second point is x1 is equal to 30. X2 is equal to 0. This is line 2. Okay, so meron na tayong line 1 at saka line 2. Okay, yan yung line 2. Ano? So, plotting these points on the graph and connecting them with a line gives the constraint line and area for clay as shown in figure 2.5. Okay, this time pagsamahin natin yung ginawa nating dalawang lines, ano? Line 1 and line 2. So, combining the two individual graphs for both labor and clay, figures 2.3 and 2.5 produces a graph of the model constraints as shown in figure 2.6. So, kung makikita nyo dito sa ating ginawang graph combining the two lines, okay, meron tayong tinatawag na yung tinatawag nating feasible solution. Dito yun, sa loob ng nandyan sa within the area ng dalawang linya na ginawa natin. Yung tinatawag naman nating infeasible solution, okay, nandito naman. Okay, beyond that, okay, yan, lahat yan. That is actually infeasible solution, lahat ng ito, ano? Lahat ng yan, okay? So, yung within that itong tinatawag na linya natin na to, yung may red, that is actually the feasible solution, okay? Nandyan din yung tinatawag nating optimal solution, which is the answer, okay, for x1 and x2 that will dun sa ating objective function na makakapagbigay sa atin ng maximum profit. Later on, makikita natin sa gagawin natin, ano? So, number 2, the optimal solution point. The second step in the graphical solution method is to locate the points in the feasible solution area that may result in the greatest total profit. So, dahil nakita na natin yung tinatawag nating feasible solution area, now, we actually have created 3 points. Okay? Point A, point B, and then point C. Hindi naman pwede maging point itong 0 na to. Kasi 0, 0 yan. So, you don't call that a point. Okay? Starting point, pwede. But, a solution area, solution, hindi solution yan, ano? So, ang solution natin dyan is, yung tinatawag nating point A, point B, and point C. Okay, so, alam na natin kung ano ang point A. Point A is 20x2. Okay, nakita nyo ba yon? Point A is 20x2 dahil x2 siya eh. Tama? Pointing to x2. Okay? And then, 0x1. 0x1. Yan yung point A. Pagdating naman natin sa point C, okay, kung makukuha ko itong... Okay, sa point C naman natin, point C is 30x1. Makikita niyo yan? 30x1. And then, 0x2. Diba dun sa ginawa natin mga computation kanina? Graphically, dahil accurate naman itong graph natin, nakikita natin, nadidetermine natin yung mga coordinates dito sa points natin A, B, and C. Now, the question is, ano yung B? Hindi natin alam kung ano ang B eh. Okay, so, ang ano dyan, either the optimal solution is A, or B, or C. But the question is, ano naman yung point C? Ano yung coordinates ng point B? Ano yung x1 niya at saka x2? Yun yung gagawin natin sa susunod ngayon, ano? Number 3, the solution values. The third step in the graphical solution approach is to solve for the values of x1 and x2 once the possible optimal solution points have been found. So, point A is equal to x1 is equal to 0 and x2 is equal to 20. Point C is x1 is equal to 30 and x2 is equal to 0. The question is, what are the coordinates of point B? It is possible to determine the x1 and x2 coordinates of point B directly from the graph as shown in 2.11. The graphical coordinates and corresponding to point B in figure 2.11 are x1 is equal to 24 and x2 is equal to 8. Kaya lang, okay, unless an absolutely accurate graph is drawn, it is frequently difficult to determine the correct solution directly from the graph. Kung sanang yung graph natin kung puro accurate, may mga 0.1, 0.2, dito sa ating ginagawa medyo madali pa eh. Pero paano kapag may 0.33? Okay, yung x1 coordinate mo, x2 coordinate 0.45, mga ganun. Paano mo makikita yun? It is almost impossible na ma-determine mo yung correct solution directly from the graph. Okay? A more exact approach is to determine the solution values mathematically once the possible optimal solution points on the graph has been determined. The values of x1 and x2 coordinates of point B can be found by solving the two equations simultaneously. Okay, so i-convert muna natin yung both equations o yung both constraints to functions of x1. Okay? So, tingnan muna natin yung parehas na value ng x1 dun sa labor constraint at saka sa material constraint or clay constraint. So, labor constraint x1 plus 2x2 is equal to 40. Therefore, x1 is equal to 40 minus 2x2. Okay? So, dun sa kabila naman, tingnan din natin kung ano ang x1. So, 4x1 plus 3x2 is equal to 120. So, ililipat mo yung 3x2 sa kabila, 4x1 is equal to 120 minus 3x2. x1, okay, i-divide mo ng 4 yung 120 minus 3x2. Kaya nakuha mo doon, 120 divided by 4 is 30. Okay, negative 3x2 divided by 4. Kaya nakuha natin yung minus 3x2 divided by 4. So, parehas na nating nakuha kung ano yung x1. Okay, sa magkabilang equation. x1 in the first equation equal x1 in the second equation. Okay, so 40 minus 2x2 is equal to 30 minus 3x2 divided by 4. So ngayon, kukunin natin yung value ng x2. Okay, so mayroon akong pinakita dito na dalawang solution. Yung pangalawa, yung solution sa book. Pero yung unang solution, parang I see na medyo mas madaling isolve algebraically pag gaganito. So, 40 minus 2x2 is equal to 30 minus 3x2 divided by 4. Kasi may 4 dun sa dulo. So, ang gawin natin para mawala yung 4 sa baba, i-multiply natin ng 4 yung lahat ng equation. Okay? So, 40 times 4 is 160. 4 times negative 2x2 is negative 8x2. 30 times 4 is 120. So, para mawala yung 4 sa baba, okay, kaya naging negative 3x2 na lang. Therefore, so kung ililipat natin sa kabila yung negative 8x2, magiging positive siya. So, 8x2 minus 3x2 is equal to 160 minus 120. Kasi yung 120 inilipat natin sa kabila. So, 5x2 is equal to 40. Therefore, x2 is equal to 40 divided by 5, which is equal to 8. Or, ito rin pinakitang solution sa libro, 40 minus 30, okay? Yung 30 na positive dun sa right, magiging negative sa left. So, 40 minus 30 yung negative 8x2 sa left, kung ililipat mo sa kabila, magiging positive. Okay? Kaya nga 8x2, okay, divided by 4. Negative 2x2 pala. Kaya 8 divided by 4, kasi yung 2 is 8 over 4. Kaya 8x2 divided by 4. Okay, meron siyang denominator na 4. Kaya para ma-minus mo yung 3 dun sa whole number na 2, okay, gawin mo siyang 8 over 4. So 8 minus 3 is 5x2 over 4 is equal to 10. Therefore, x2 is equal to 8. Substituting x2 is equal to 8 into either one of the original equations gives a value for x1. Okay, so i-substitute na natin yung 8. Alam na natin kung ano yung x2. So, dun sa unang constraint, tama, x1 is equal to 40 minus 2x2. So, i-substitute natin. Makukuha natin x1 is equal to 24. Okay, so, dahil nakuha na natin yung x2 at saka x1 is equal to 24. Okay, and then x2 is equal to 8. Thus, the coordinates for point B are x1 is equal to 24 and then x2 is equal to 8. Substituting these values into the objective function gives us the following profit for point B. So, sasubstitute natin doon sa ating objective function, okay, or yung profit formula natin, z is equal to 4x1 plus 50x2, z is equal to 40 times 24 plus 50 times 8. We will get a value of 1,360. Ang tanong, is this the maximum profit? Hindi pa natin alam. Ano? Point A, okay, alam na natin kung ano yung point A eh. Through the graph, kung maalala nyo yung graph na ginawa natin, o yung pinakita natin, nandoon yung coordinates ng point A. So, substituting the values to our profit formula, okay, z is equal to 40 times 0, which is x1, plus 50 times 20 is equal to 1,000. Okay, so mas mababa. Point C, x1 is equal to 30, x2 is equal to 0, will give us a profit of $1,200. Kasi 40 times 30 lang. Therefore, thus, the optimal solution is point B. Okay, x1 is equal to 24, x2 is equal to 8, which will give us a maximum profit Z of 1,360. So, point B is the optimal solution. Okay? Sa libro natin, pinakita ka agad na yung point B is the optimal solution. Pero dito, pinakita ko na optimal solution yung point B dahil pinakita natin na siya yung may pinakamataas na profit. Okay? Dinahandahan muna natin para kasi hindi naman necessaryong baka isipin, yung point sa gitna ang laging optimal solution. Hindi sa lahat ng pagkakataon. Okay, meron mga pagkakataon na point A ang optimal solution. Meron mga pagkakataon na point C ang optimal solution. Not necessarily point B. Okay? Solutions at all corner points. So ito yun. Figure 2.12 shows the solution values for all 3 points, A, B, and C. and the amount of profit Z at each point. So obviously, point B has the highest or maximum profit among the three. Meron tayong tinatawag na slack variables. A slack variable is a variable that is added to an inequality constraint to transform it into an equality. Diba matatandaan nyo yung mga formula na ginagamit natin dun sa labor constraint at saka dun sa clay constraint. Laging meron siyang lesser than or equal to. Diba? Lesser than and or equal to. Ang slack variable, it is a variable, okay, that is added to an inequality constraint to transform it into an equality para maging equal sign, ano? Ang pinag-uusapan natin dito in our example, a slack variable would mean a portion of unused resources. Okay, so kunwari dun sa unang constraint x1 plus 2x2, pagka yun lang kasi, hindi mo kasi malalaman kung ilan yung hindi nagamit na labor. Okay? O dun sa clay constraint, kung ilan yung hindi nagamit na clay. So by adding a slack variable, malalaman natin yung unused resources natin. So the complete linear programming model can be written in what is referred to as standard form with slack variables as follows. Okay, so yan yung magiging bagong ano natin, which is yung tinatawag na standard form. Okay, so malalaman natin dyan kung ilan yung mga unused resources natin. The solution values including the slack at each solution point are summarized as follows. Okay, so nakasulat dyan, ano? Medyo madali natin intindihin. Kung makikita nyo sa point B, wala siyang slack variable. Ibig sabihin, lahat na gamit. Walang nasayang na labor, walang nasayang na material. Okay, sa point A kasi 60 pounds pa ang hindi nagamit na clay. Sa letter C naman 10 hours ang hindi nagamit na labor. So makikita natin dito yung point B, hindi lamang niya na-achieve yung maximum profit, na-maximize din niya yung paggamit ng mga resources. So, kung babalik tayo dun sa ating graph, figure 2.14 shows the graphical solution of this example with slack variables included at each solution point. Okay, so sa bawat point A, point B, point C, pinapakita dito sa graph na ito yung mga tinatawag nating solution variables nila including the slack variables. So summary of the graphical solution steps. The steps for solving a graphical linear programming model are summarized here. Number 1, plot the model constraint as equations on the graph. Then, considering the inequalities of the constraints, indicate the feasible solution area. Number 2, solve simultaneous equations at each corner point to find the solution values at each point. So, tatandaan natin na sa number 1, okay, ipa-plot natin, gagawin muna natin yung line 1 at saka line 2. Okay? Para malaman natin yung feasible solution area. Okay, yung gray area dun sa ating graph. Okay, kung saan nakapaloob. Okay, dun sa within yung tinatawag natin dun sa dalawang lines. So, pag nakuha na natin yun, number 2, solve simultaneous equations at each corner point to find the solution values at each point. So, pag nalaman na natin kung ano ang point A, ang point B at saka point C, isolve na natin. Okay, paano gagawin natin? So, para malaman natin yung value ng point B, okay, titingnan natin dun sa ating mga constraints kung ano muna yung value ng x1. Okay, pag nakuha na natin yon kung ano yung x1, isa-substitute natin yon dun sa isa man, kahit ano dun sa dalawang constraint para makuha natin yung x2. Okay? And then number 3, substitute these values into the objective function to find the set of values that results in the maximum z value. Pag nalaman natin yung point A, kung ano yung x1 at saka x2, i-compute natin do sa z. Ganon din sa point B, point C. At kung alin yung may pinakamataas na value, dahil maximum tayo dito, maximum profit, yun ang optimal solution. Okay? So, I hope naintindihan niyo yung lesson natin ngayon, maikli lang yung time natin. Kung sanang mas marami pa tayong time, mas mai-explain ko pa ng mabuti sa inyo. But, this is only the time that we have for this video. Anyway, sa mga susunod nating mga klase, magkakaroon pa tayo ng mga further explanations at saka mga problem solving concerning model formulation and the graphical solution ng linear programming. So that's it. Thank you very much for joining me in this lesson. I hope marami kayong natutunan. Kung meron kayong mga tanong, ay ihanda nyo lang yung mga tanong na ito para pagka nag-Zoom consultation meeting tayo, mapag-usapan natin yung mga tanong na yun at hopefully masagot natin para malinawan kayo sa ating mga pinag-aaralan. Okay, thank you very much and God bless.